Hello, Year 8. We're going to carry on today with temperature and energy. So our title today, Temperature and Energy, we're learning about temperature and thermal energy and some examples of how these two things relate to each other. So important start, we can do this first, is make the for your notes. So important to stop the video, give yourself a bit of time to make these notes as we carry on, and we'll try and answer some questions later on. So temperature is the average energy per particle. First note. All substances are made of particles. Water is made of water particles. Your table is made of particles. Iron is made of particles as well. And even though something might have really high temperature, if it's small, hotter things can have less energy than colder, larger things. Okay, so 2 points for your notes. So we'll give an example here. Strange thoughts. This bath of warm water actually might contain more thermal energy than the kettle of boiling water. So the kettle might be at 100 degrees. The bath might be at 50 degrees. It might be quite a hot bath, actually. However, how many more particles, which one of those has got more particles of water in it? Is it the bath or the kettle? You're absolutely right. It's the bath. So because there's more particles of water in the bath, even though they contain less energy per particle, right, than the kettle, the particles of water in the kettle might only have, let's say, that many particles. Because each particle still does have some energy, if we add them all together, we've got more energy in the bath than we do in the kettle, even though the temperature is different. So let's try and explain this then, shall we? We're going to use this model. Just here to help us. Okay, so this picture here is what we're going to look at now. Now, let's imagine this picture represents a small beaker of water. Each child is representing a particle of water. This picture here, number 2, so this is the one. Picture number 2 represents a large beaker of water. Because each child representing a particle, there's many more particles, aren't there? Okay. Now, if we look at the money that each child is holding, this is a 2p piece, or let's say 2 baht. Each child in this picture is also holding a 2 baht coin. Now, if there's 20 children in the small beaker of water, or 20 particles in the small beaker, each child has 2p or 2 baht. We can calculate the amount of energy in that small beaker. So 20 children times 2 baht gives us, you got it, 40 baht. Now, if we look at this beaker, we have more particles. We have 100 children. Okay, so many more particles. It's a bigger beaker of water. Still, each child has the same amount of energy per particle, so 2 baht or 2p. So we can say they're the same temperature because each child has got the same average energy per particle. Now let's work out the total energy, 100 times 2. Work that out. Nice and easy. It's 200. And actually, if we say, actually they're joules rather than baht now, we can say the small beaker actually contains a total of 40 joules. The large beaker contains 200 joules. So even though they're the same temperature, we've got way more energy in the large beaker of water than we have in the small one. And essentially that we can take that forward. It may be a good idea for you to write that example in your books. Okay, that is a great example to use. Stop the video and do that. Here's another great example. Now we're going to change the average energy per particle. So if we look at this, we've got 2 children here, 2 particles, each with 5 baht. Here we have 6 children, each with 2 baht. Okay. So which of those, 1 or 2, has the highest temperature? You're correct. Picture number 1 has the higher temperature because they have 5 bits of energy per particle. Picture 2 only has 2 bits of energy per particle. Now, can you work out then how much energy total there is in each picture? Picture number 1, good. We've got 10 bits of energy, 10 joules. Picture 2, right, good. We have 12 joules of energy. 6 children with 2 joules per particle. Okay? So, even though this one is the higher temperature than picture 2, picture 2 actually contains much more energy. So this is a great example to get into your books as well. You're thinking about temperature and energy in terms of the amount of energy each particle contains. Okay, I'm going to stop the video there.